In this video, I'm going to go through how to calculate the degree of hydration of water crystallization, or the number of moles of water of crystallization. I'm going to use the data that you see here on the screen. So when you come to do this type of calculation, you should remember that you're trying to work out the number of moles of the anhydrous salt, that's it without water crystallization, and the number of moles of water. So I'm going to use copper sulfate again as the example. So the data represents values for heating hydrated copper to sulfate. I'm going to sketch out a table. Here we've got anhydrous copper sulfate. That's what this is, anhydrous copper sulfate. And this column will be for the water. So the first thing I've got to do is work out the mass of the anhydrous salt. So I'll go to the results. Here is the crucible plus the anhydrous salt, so that's it after it's been heated to constant mass. And if I subtract the mass of the crucible, which is here, that difference will be the mass of the anhydrous, the dry salt. So it's going to be 28.126 minus 18.742. That's 6.384. Now I work out the mass of the water. So I'm going to look at this value, because that's the crucible plus the hydrated salt. And this is the crucible plus the anhydrous salt. So this difference, or this loss in mass, is due to the water being driven out of the hydrated salt. So it's going to be 28.726 minus 25.126. And that works out to be 3.60 grams. Put the G in there. Now that I've got the masses of the anhydrous salt and of the water, I can convert those to moles. This is going to be 6.384 over the MR, or the RFM, of copper sulfate. That's 160. That equals 0.040. The moles of water will be 3.6 over 18. That's 0.2, or 0.20. The next thing I have to do is convert these moles into whole numbers. And I do that by dividing by the smallest number of moles, which you can see is the 0.04. So I divide both of these values by 0.04. So this will obviously become 1, and this one will become 5. Now when you do these calculations, the number of moles of water will always be close to a whole number. You don't need to multiply it up by 2 or by 3. So now I can work out the actual formula of the hydrated copper 2 sulfate. It would be CuSO4.5H2O. Here's another example. So I have to work out the degree of water of crystallization, or the formula of the hydrate. So again, I'm going to sketch out the table, and it's going to be the ratio of the anhydrous cobalt 2 chloride to the water. Now, I haven't been given any details about the crucible here, so I can just use the values in the question. After heating, the sample weighed 1.20 grams. So that's the mass of the anhydrous cobalt 2 chloride. The water can be worked out by subtracting the mass of the dry sample, or the anhydrous salt, from the original hydrated salt. So this value here is the cobalt 2 chloride, including the water. So 2.38 minus 1.20, that will give me the mass of water, which is 1.18. The next thing I do is calculate the number of moles. So those were masses. Then moles will be 1.20 over the MR of cobalt chloride, 130, and that equals 0.0092. Do the same thing over for the water, 1.18 over the MR, which is 18, and that's 0.066. I've got to then convert this into whole numbers. So I divide by the smallest number of moles, which is 0.0092. That'll turn that into 1. And that will give me 7 water molecules. So the formula for hydrated cobalt 2 chloride is COCl2 dot 7 H2O. Now, I'm going to point out that sometimes if you were doing this in a lab, you're actually carrying out the practical, the value can be greater or less than the actual value that's stated in a textbook. And I'm talking about the value here, the degree of water crystallization. So if the value is smaller than expected, that indicates that the sample hasn't been heated to constant mass. In other words, there is still water crystallization present. And sometimes the value that's obtained is greater than what's expected. And when you get a value that's larger than expected, that probably means that the hydrated salt has been heated too much and it has decomposed. So for example, copper 2 sulfate or hydrated copper 2 sulfate decomposes fairly readily. It needs to be heated quite gently. Copper sulfate will decompose into copper 2 oxide and sulfur trioxide, for example. Now when it decomposes and releases the gas, then that makes it look as though there's more water crystallization present than what is actually there. So you imagine the salt, you heat it, it drives off the water crystallization and then it's all gone. But if the hydrated salt has decomposed into other gases, the mass of the anhydrous salt will decrease further. But that's not due to water being lost. It's due to the fact that it has decomposed. Have a go at the following question. So this is for barium chloride. So what you've got to do is work out the value of X. So pause the video, try it, and then press play to check your answer. Right, let's look at the answer to this one. Again, I'm going to sketch out the table and I'm going to write down the barium chloride. So this is going to be the anhydrous barium chloride and the water. I'm going to determine the mass of each of those parts of the hydrated salt. So the mass of the anhydrous barium chloride is worked out by looking at this value, which is the crucible plus the salt after it's heated. So remember, that's when the water of crystallization has been lost. That's it dry. And then if I subtract the mass of the crucible from that, that will just leave me with the mass of the dry salt. So it's going to be 43.26 minus 42.22. That works out to be 1.04 grams. Next, I calculate the mass of the water. So here is the crucible plus the hydrated salt that's containing water crystallization. This is the crucible plus the salt minus the water because it's now dry. So the difference here is due to the water of crystallization being lost. So 43.44 minus 43.26 is 0.18. That's the mass of water of crystallization. Next, I convert these masses to moles. 1.04 divided by the MR, or the RFM of barium chloride. That's 208. That equals 0.005. The moles of water is going to be 0.18 over 18, 0.01. Divide by the smallest number of moles, which you can see is this one. So that becomes 1. This is 2. So the formula of hydrated barium 2 chloride will be BaCl2.2H2O.